everybody, Dutch Sense here. 7:04 p.m. Central Time on June 30th, 2015. And I've got you looking at Earthquake 3D, which is a USGS feed of the most recent earthquakes. And right now we're looking at the last 24 hours of events, 2.5 and greater in the continental US. And right off the bat, I'm just going to tell you, if you're into geology, you're either going to love me or hate me by the time this video is over. And I just want to go ahead and get it right into this and delve into the earthquakes that have struck over the past 24 hours in the Midwest. And let's just take this down just a little bit more beyond 24 hours so you can see the activity that also struck across Mississippi and Alabama late yesterday. Now, I'm going to show you an article that's on multiple mainstream news sites, but here's one. Second Michigan earthquake in 2 months puzzles scientists. And we can look at it on Earthquake 3D here. Here is a 3.4 that struck in central Michigan. Now, you may remember just a month and a half ago, a larger earthquake struck here that caught everybody off guard, and that was in the upper 4.0 range. And again, it was in central Michigan at an area that doesn't normally see earthquake activity. Same time frame we saw that happen, we also saw an earthquake strike on the New Madrid seismic zone, and we saw an earthquake strike down here in central Mississippi. Now, I'd like to show you what's at these locations down here to the south, and then we're going to explain to the scientists, to the geology students, geology majors, and professionals what's actually happening and how this all ties together. Now, you're going to see a swarm of earthquakes over here to the west. That's in Oklahoma-Kansas border. Those were all fracking operations. Each one of these over the last 24, 48 hours, definitely fracking induced. You can go see the wells at each location by looking up the coordinates on the USGS. And to look up the coordinates, no matter which way you want to do it, don't use USGS service. It shows you grainy images, old outdated satellite views, aerial views as opposed to high quality satellite imagery, and I recommend that you use Google Earth. Also, you can place your own place marks. Makes it a lot easier to keep track of things. So here's Google Earth, and we're going to get the coordinates from the USGS for the earthquakes down here to the south first. Now, 2 earthquakes preceded this movement here in Michigan, just like last time, guys. Before the Michigan earthquake, a month and a half ago, there were earthquakes down here at the south portion of the Craton that we don't normally see. And one of those earthquakes struck at the exact same location, and that's here south-southwest of Canton, Mississippi. And we'll get the coordinates on this from the USGS. Now look at the depth, 5 kilometers plus or minus 2, so that puts us anywhere between 3 to 5 kilometers. And let's copy the coordinates, put them in on Google Earth, hit search, and this will bring us in on the coordinates of the epicenter of the earthquake. Now, I already know it's here, but I'm going to let it load and show you. Okay, see this? This is the Nissan factory, or if you're from Europe, Nissan factory right here. Now, this is closed right now due to retooling. And the last time that we saw an earthquake strike here, they were closed for retooling. Now, I'm willing to venture a bet that they're doing something else there. Something else is going on at the Nissan factory that's not related to car building, that's causing earthquakes at a deep level down below, and it's happening somewhere in this location nearby. Now, we have a track here that's shaped almost like a giant Wi-Fi antenna or a giant loop antenna of some kind. But that would be, of course, VLF of some kind out of something that size. I don't know what to make of this. But 2 earthquakes there in the last couple months, very, very strange. Now let me show you the other earthquake that struck just due east. 3.8, 3.9, northwest of Utah, Alabama. We're going to do the same thing. We're going to get the coordinates from the USGS. Copy. Paste them in. And we'll get into Michigan in a second. We're going to address why this is happening, but first I got to show you where these are happening so you can get a better understanding. Now, we already said that the Oklahoma earthquakes were all fracking induced, right? And you can prove that to yourself. You don't need me to show that to you. You can look up each coordinate. Again, this is backed by the USGS. You can see the frack wells at each location in Oklahoma. But this location here in Alabama, okay, it's a previous 3.9 location, so we have a 3.9 right here. 3.9 struck November 20th, 2014, 3.0 on June 6th, and a 3.1 February 27th. So a lot of activity right here. And when you're looking at this, you're going to see several roads going back into the woods where we have clearings, small little cutout clearings, and with nothing at them. Nothing at each one of these little clearings. Now, I'm going to show you something that's just amazing. About 15 miles away, right across the county line, we have new fracking operations that have been put in all throughout here. Each one of these locations is a different oil and pumping operation. Let's just zoom in and show you. These aren't houses, guys. We'll let this load. Okay, each one of these is a pump and a wellhead, and it goes on for miles and miles and miles in all directions. And it just keeps going and going and going. Now, what they did was they moved the operation. This obviously got depleted down here, and they moved the operation up to around Tuscaloosa. And we're talking, again, each one of these, they're not houses. There we go. Okay, you can see right there. See the shadow and the outline of the oil wellhead. The pump actually itself right there. And it just goes on and on and on each one of these. Okay. And new roads, new pads. So this is a new operation, of course. Now they moved this up to the north. And again, the old location was down here to the south. Probably drained that off as much as they could. Now it's seeing earthquake activity. Okay? So, now, let's get into one more thing before we go look up this earthquake up here in Michigan. These all fracking. This 3.9 here fracking. 3.2 at the Nissan factory for some reason. 2.5 on the New Madrid seismic zone, which falls right in between all three of these areas. So whenever we see these three areas move, we see a New Madrid follow-up earthquake after all those others. But what I'm going to show you now is super profound. It ties into everything that we're talking about here. And this is a breaking story, breaking across all mainstream media today. And here's my description. I posted this on Facebook, but I'll read it to you. Helium-3 is being forced up from below the crust, from the asthenosphere. The helium-3 is coming up through deep California fracking oil pumping operations. Deep wells not only showing helium-3, but also showing metamorphic rock upwelled from below at the bottom of the wells. And as I say, this is huge news because magma is coming up from below to meet the base of the deep drilled shafts. Helium-3 is expanding out from the mantle of the Earth, and it's showing up at the fracking operations at the surface, proving a direct connection between the asthenosphere and the surface drilling operations. Water drilled into these wells, meeting metamorphic magma from below. What do you think happens when water meets hot rock? Steam plumes occur, earthquakes, followed by heating and fires once the water's gone. This is all happening at fracking operations. And we can go to the article where they talk in depth about what they found. And again, they found that helium-3 is upwelling from deep below in the asthenosphere and the melted magma below the plates. And it's coming up at the fracking operations in California, Los Angeles. And there's also metamorphic rock that's upwelled from below that's meeting at the bottom of these deep drilled wells. And there's earthquakes that are happening at those deep drilled wells. Now let's get back over to what we just looked at. Okay, we looked at the earthquakes down here to the south, and you can again look up any one of these earthquakes here in Oklahoma. Let's just do that. For anybody who's a denier or a skeptic still on the Oklahoma fracking earthquakes, we'll do the same thing. You get the coordinates from the USGS. Okay, here we go. And we'll put them in on Google Earth, and we'll do the same thing. We'll look them up and see what's at the earthquake epicenter. I know this gets repetitive, a bit mundane if you're a viewer of mine for a long time, but I'm doing this for the new viewers, for the students, for the teachers, for the people in the industry who don't do this, the people who don't look up the earthquake epicenters. They don't know. Look at all the time I've taken marking these wells so that we can know what's at each location. Okay, here's our 3.0 earthquake. Now, we've got, looks like $1 million mansion, right? Several. Look at the size of those houses, right? Oh, what do we got here? What do we got right here? That's right, guys. A frack well back in the woods, back behind the $1 million houses. And again, we've got a highway right here. And another series of older frack wells there. And you can see the tank, you can see the storage apparatus. And it's a previous earthquake location. And it's just one of many. You can come throughout the area and check out the different operations that they have here. And it goes all the way south. And it's right next to a lake. I mean, that's another way to look at it. Look at this. I mean, they're doing deep water injection wells where they're injecting best case scenario, brine, a worst case scenario, wastewater, down into the earth right near one of these large water sources. Get an earthquake there, fractures it, next thing you know, it starts going out into the water that people are going to be swimming in, eating fish from, that sort of thing. Okay, so that's the earthquake right there. I mean, just go look it up. I mean, frack well right there at the earthquake epicenter. Now, I would be willing to venture a guess. If metamorphic rock is coming up down here in Southern California and helium-3 coming up from the asthenosphere down below, and there's a connection between the mantle and the surface at these operations, and it's causing earthquakes at these operations here on the West Coast, if the same studies and tests that were done here in the Midwest, we might come to find out that helium-3 is being released here as well, and that metamorphic rock is welling up from underneath, deep below the craton itself, causing displacement around the entire western, southwestern, and central edge of the craton, which then displaces areas to the north-northeast. And now let's get into this earthquake up here. Why are earthquakes happening here? Geologists are puzzled, right? They say they don't know what's going on. Oh my gosh, we don't know what's going on, Michigan. We can't figure it out. We don't understand why this is happening. Now, I'm going to show you guys something that most people don't know about. I'm going to turn this down. Well, I guess we could play it. It's really loud.
At Indian Hills, it smells like propane. I don't know if you can see it, but if you look right across, right above the green, there's this haze that looks like a gas.
Okay, so what is that? That is methane. And they said that's a natural release of methane coming from the ground. And where is this location? Well, let's go look it up. Let's back this out. Okay, here we go. And we'll bring it right on up here. And the location in question that is experiencing that large release of methane out of the ground is just north of Detroit, right along Lake Huron, right in this region here. Okay, so we have a region right in here, a golf course where that's happening at, okay, in Lambden Shores right here. Let's compare that to where the earthquakes are happening throughout Michigan. We've got earthquakes happening down through here, and then now we have a giant methane release happening right here. Well, the methane release and the earthquakes are both going to be caused by pressure on the central portion of the craton, which is coming from the area to the south-southwest. And the reason it's going there, the reason it's actually popping there, is because the edge of the craton is literally catching basically a skip over where we would normally see earthquakes happen up the east coast. Instead, we're seeing it transfer from this location down here to the south, down to the south here, where it then transitions straight up to the north, where we see earthquakes happen now up here, pressure transferring from due south, due north. Instead of northeast, north. And this past week, let me go ahead and show you something else that happened. Okay, this is another way to look at it. Look at it this way. A 3.4 struck up here in northeast Quebec, right along the edge of the craton. And if you follow that down here through Michigan, look at the rise in elevation, and luckily we're looking at an elevation map here, and that exists throughout central Michigan. Okay, my whole system's crashed. I had something just playing in the background that no reason. Things are not freaking opening. The video's starting to crash, and I can't even open up and show you guys what I want to show you. Isn't that weird? Okay, so now that this is sorted out, so when we look down here upon the northeast, you can see a 3.4 landing upon the northeast edge of the craton, and then a 3.4 again right here in central Michigan, and then due south 3.2, 3.9 in Mississippi and Alabama. That lets you know there's a connecting line between here through central Michigan and down to the south, then back up to the northwest. So we've seen it happen now 3 times, where there's been earthquakes down here to the south, happens again up here to the north, and then further up to the northeast. And that defines the central deformed edge of the North American craton, which extends throughout the northeast states of New England, going down through the south down here through South Carolina, Tennessee, and extending further west. So we have a huge amount of earthquakes happening here, and this all ties together. So the helium-3 coming up from below, confirmed in California, someone should be doing the tests at this point in Alabama, also in Texas, also Oklahoma, Kansas, and Colorado. The areas that are experiencing earthquakes that they can't explain need to be watching for that. Up here to the north, methane release. Again, methane release right here along Huron, and now earthquakes over the past month and a half also in the same area. Those two are related. All due to craton pressure welling up from deep down below, causing metamorphic rock to rise up to the bottom of these wells, causing the earthquakes. It's now all starting to tie together. New facts come in. It starts to make more sense as we go along. This was all denied for the longest time, that there was even a connection between fracking and earthquakes, or that the craton would experience earthquakes across an entire region in a day. Those things were denied for the longest time. But now, again, you can see over the last 24 to 48 hours, again, the whole craton has been displaced from the central, south, to the north, at least on a 3.0 level or greater, and that's a lot of movement to see on an area that's not normally earthquake prone. The methane release is the troubling part. This starts getting into something that is really a huge problem, which is if we start to see giant methane releases, that will then quickly give way to fires. So first methane, then fires. And that might be what we're starting to see in the far, far Arctic North, where there's no thunderstorms to cause fires, and we're seeing fires pop up everywhere. That might be a result of the same thing that happened down here in southeast Canada, which is the methane release. And if you don't understand what's going on down below the Earth, there's frozen methane. Compacted, frozen methane. There's all kinds of theories for why it's there, but entire layers of it throughout the entire planet, especially further north. Some believe that it has to do with compacting of biological materials over time, which don't have time to decay due to the temperature, and then that then translates out into frozen methane over time. There's other people that believe it's natural from the Earth's formation. There's other people that, there's all kinds of wild theories about where the methane came from. Regardless of where it came from, it's frozen methane down in the ground. And there's some people who believe that as global warming, quote-unquote, happens, climate change, that the tundra then releases these methane clouds. And we've seen that happen over in Russia with those strange holes that blew up out of the ground. Well, I bet if you were actually out there in Siberia to see that, you might actually see a giant storm form from that because of the amount of methane released and the CCN formation that would happen off that. CCN is cloud condensation nuclei, or water droplets that form around other small microscopic particles, like methane gas, for instance. So, this could be happening up here to the north, and those giant wildfires that we're seeing pop up everywhere might just be versions of what we saw down here that didn't catch on fire, right along Lake Huron. Again, when you saw that methane release down here, and you see earthquakes happening right there, look at the elevation of this, and you can follow this right up along the inner edge of the North American craton, let's call it that, instead of the outer edge where we were seeing earthquakes happen before. For instance, down here in Virginia, remember the 5.9 that struck in Virginia in 2011? Or a series of 4.0 earthquakes that struck along this region? Okay, all those stopped, and now we started to see 4.0s on the back side, on the back edge of the craton. And that takes us in right to where you can see the mountain ranges that extend up here. And of course we have our river valleys, which is nothing more than a split in the craton itself, which you could call the Great Lakes then, just a crack or depression in the central North American craton, not formed by glaciers, like they said. Again, this flies in the face of all geology, and like I said, you're going to either love me or hate me by the time this is over, and what I'm telling you is that pretty much the entire formation of the North American continent that you were told the way it happens is exactly the opposite. That really we see upwelling pressure and craton pressure come from the west-northwest. Subduction does not take care of that. Instead, it causes buckling and pressure to form upon the edge of the craton, forming mountain ranges, foothills, over a long period of time. In some cases, a short period of time, inches rise in a year, let's say, half inch across the entire state of California, or 3 inches in 6 months across the entire region of Yellowstone going into Idaho. Okay, that happened. just this past couple of years. And so we can see rises happen in inches, not centimeters, and it'll happen quickly in a year's time, not 100 million years' time. And why would that happen? Again, excessive pressure upwelling from down below, which causes then earthquakes up above, most likely steaming events of some kind to happen in areas that are volcanically prone, also drilling operations. This could explain our weird weather patterns that we're seeing develop all throughout the volcanic ranges going throughout this region here. Day after day after day. Steam plume after steam plume. Everybody wants to just say it's regular storm formation. I challenge that notion at this point and say that maybe what we're seeing here, and if you don't know what I'm talking about, let me just go ahead and show you. Again, like I said, you're going to either love me or hate me by the time this is over. I don't care which it is. Let's just go ahead and look at a regional view of the South Central. Let's take it over one notch. Let's take it over to the southwest so you can get a better idea of what I'm talking about here. Every day, especially on times when we have high solar activity, people might mistake this for regular storm formation, but let me just let you see what I'm talking about. That where we see these giant steam ups, and this is again storm formation, no doubt about it, hail, damaging winds, but that the source of this isn't coming from the atmosphere, that the source of this is actually coming from a ground source, and that these mountain ranges are formed from upwelling down below. And it flies in the face of how North America was formed. This area would have formed like an old island chain, like Hawaii, let's say. Okay, imagine this area rising up out of the ocean first. And then an inner sea trapped in the inside around this entire mountain range, which at some point broke and gave way and drained out through the Grand Canyon, down through California, and out through Texas, away from this inner sea, which we know was an inner sea, no doubt about it. But that flies in the face of everything you're ever taught. And that this steaming that we're seeing here happen every day is really an upwelling, and that the mountains are really rising, and we're seeing a dramatic rise happen, not a small one, and it's based upon a greater continental shift that's happening over an entire plate. Now, could that be happening? I don't know. It's just a hypothesis at this point, but it's one that makes sense to me. If you don't agree, venture your own hypothesis as to how we're seeing earthquakes transverse across an entire plate in a day or two's time. Methane releases happening like a geyser in areas where we would expect to happen if plate pressure would be upwelling from below. That we're seeing earthquakes happen in diverse areas below fracking operations in other areas, now confirmed to be upwelling from below with metamorphic rock and helium-3 from the inner mantle of the planet. So, overall, guys, we get back to this article. I hope geologists wouldn't be confused if I were to explain it this way. That you shouldn't be puzzled when you see earthquakes happening right next to an area that just had the biggest methane release ever caught on camera. Happening right here along the lakes. Why is that happening? Plate pressure from below. Proved now, metamorphic rock coming up down here. If it's happening there, we need to check for it here. And if it's happening here, then you can sure as hell bet it's happening down here. And if it's happening down here, then, well, you know, it translates out up the northeast that upwelling pressure would also happen here as well. Something to worth look into for sure. If you're a graduate student, if you're somebody who's interested in these things, you need to not just take the official word, which is no word, really, that there is no word, no one's linking the earthquakes here to the methane release right there, even though they're right next to each other and happen within weeks of each other. Why not? I guess people just aren't paying attention. Maybe the censorship's too hard. They worked really hard to censor that methane release story. And then they worked really hard to downplay these earthquakes as really small, even though it was the largest to hit in state's history just a month ago. Or at least since the 1940s or whatever. That it's been years since there's been any earthquake activity there. And the last time there was earthquake activity there was greater global activity happening elsewhere. So it does all tie together. Deep earthquakes in the West Pacific cause shallow earthquakes in the West Pacific, which translates out to pressure in the United States from a direction coming from the opposite direction as normal, which then causes a displacement and upwelling on the craton itself, causing displacement at dormant volcanoes, fracking operations, and then we see earthquakes spill across the edge of the plate, and everybody's puzzled and wonders what's happening, but that's the explanation. That the West Pacific displacement is causing a full Pacific displacement, displacing the United States, displacing it from underneath, causing a displacement at the fracking operations, which then we are all shocked to see translate out as earthquakes. So I hope this explains to you what's going on, guys. Will it stop? Well, we'll have to wait and see what happens here in the West Pacific. As soon as all this calms down and you look at the last 7 days again, last 7 days, it's still looking like it has looked. And look what happens in the United States. As a result of the movement over here, we start to see the movement happen over here, including Hawaii. 5.2 earthquake, and, nobody talking about it right at the volcano. No eruption, but, 5.2 hasn't happened there in years. We haven't seen any movement like that in a very long time. Mount Hakone erupted yesterday, and that hasn't erupted in over 800 years, almost 1,000 years. Just like in the United States, the dormant volcanoes that are showing movement here in the States, they also haven't erupted in 800 to 1,000 years. So it looks like the last time that any kind of big volcanic activity happened globally was 800 to 1,000 years ago. And if that's the case, then it looks like we're repeating that event now, and what coincides with 800 to 1,000 years ago. That takes us back to the last real mini ice age. That takes us back to the Middle Ages. Right after the Dark Ages, Middle Ages, before the Renaissance, before the Enlightenment. We're talking about a great, dark, dreary time across most of Northern Europe. Cold, they always depict it as being this backwards fiefdom with muddy, cold pits of people, and that's throughout all of Europe. And we can pretty much bet that that was the result, that mini ice age was the result of all the volcanism putting so much particle matter into the air, which then drops global temperatures and caused that real mini ice age. Now, again, there's some people that say that happened again in the 1800s. That's up for debate, but for sure it's confirmed to have happened in the Middle Ages, and that coincides with all our volcanic activity. One final thing, those steam plumes, all that activity that we were looking at on the weather map there, extending throughout here. I'm going to go ahead and show you something really quick. We'll turn it on Google Earth. This is the Smithsonian Institute's global volcanism programs, and let's just go ahead and turn those on. There we go. Okay, so you can see here marked out along the edge of this mountain range, so to speak, and it's not really a single mountain range. You could call this the Rocky Mountains, but it does extend far west into Nevada, that this whole area at some point was an inland sea. You can, no doubt about it, you can go check it out for yourself, look at all the material on it. Inland sea extending all the way up here to Yellowstone, and you can even see where the old shorelines of this old inland sea used to exist. Now, the real question that you got to ask yourself is, here at the highest point in the country, throughout here, we've got the mile-high city of Colorado here, and then going even higher elevations up here in Wyoming. At some point, this was underwater, but there were peaks that were above the water, and like volcanic islands, these islands grew like Hawaii would, for instance, and formed mountain ranges a long, long time ago, hundreds of millions of years ago. This formed an inland sea that became trapped in here, and that at some point flowed out. Now, there's some people that say that that's what caused the Grand Canyon, and that the Colorado River just flows through there now by chance, but that really it flowed out, that this giant ocean flowed out in two directions out here to the south at some point when either the water got too high or one of these volcanic ranges blew, and when it blew, of course, it opened up the sea, and the sea flowed out down here to the south, depositing sand and sediment all throughout here to the south and to the west, which, if you really look at it, this kind of does look like some kind of, sediment flow, so to speak, and that would explain why the sand dunes are here in western Colorado, southwest Colorado, the Great Sand Dunes National Monument. Why are there giant sand dunes there? Well, there was an ancient ocean that was here, and it wasn't just blown in from out of state, guys. They tell you that, but I'm telling you, there was an ancient ocean here, and if you really want to go look, you can verify this and talk with other geologists, that the ancient ocean existed throughout here. And the volcanic locations exist throughout here, and all of these are volcanoes. So you got one, here's Sunset Crater, right? Well, what about this volcanic field here? Okay? And these are old undersea volcanoes. There's no doubt about it. Okay? You might call these mesas, but these mesas are nothing more than an old volcanic field throughout the entire area. And look how big that is. That's just one area of many, and you can follow it all. Here's another active flow. But we have others down here to the south that are much older, that are hard to make out because they look like they're part of a mountain range. But if you really zoom in on the areas, you'll see, well, they're covered with trees, but you'll see that they match up almost exactly. And there's no doubt about it. You have old craters inside of these. Okay. But it's not marked by the USGS, and it just goes on and on and on and on and on. And all of these, and I mean, really, I challenge you to come in and look at these areas and really inspect them, and you will see that it's made up of many old flows that are not marked by the USGS. Here's another one. Okay, Jordada de Muerto Volcano. Okay, now pardon my Spanish, but okay, look at the old flow here. I mean, these just exist throughout the entire area, and they go on and on and on, especially over to the western portion here. Goes up to the south. These are all marked by the Smithsonian Institute, but there's so many more that are not. And then you got to ask yourself, okay, if this whole chain here is volcanic related, and that this formed undersea a long time ago, not like they told us that it formed in some other way, that this whole area here, again, you saw the steaming happen at the start of this video. These are the areas that are steaming. And you could say Dotsero up here, but there's many more down here to the south. And in case you don't believe me, let's just go look at the New Mexico-Colorado border. Okay, you can even make out, okay, what is this called? Cerro de Air. But you can make out the old crater on this and the old lavic flows, and of course the trees flock to that. The trees will grow well in that because of the high nitrogen content of the old lavic flows. So it's no shock that we see, you know, right up against the desert sands, trees forming on these old flows. I bet you if you were to test it, you would see the nitrogen content much higher. So there's no doubt about it, each one of these locations, and you can even see the old lavic flows here. And I can show you another location. Okay, just see that right there. Okay, just to show you that that is indeed lavic. We can come over here to California. Okay, and here's a good example right here. Here's an old cone volcano, and you can make out the flow on this. Let me go ahead and turn this sideways. And again, this is a California lava flow out in the Mojave Desert, so it isn't as weathered as you might expect there at the Colorado-New Mexico border, but you can make it out. There it is. It's the same kind of undersea lavic flow that you might expect. Now, that means that the area was underwater at some point. And that means that this entire area was underwater. And that would explain the layout of the land. But where did it all go? Where did the inland sea go? Apparently the inland sea existed exactly where you would expect it to exist, throughout here, going over to here, and bordering along through here. At some point, this rose higher, the volcanic ranges rose higher, and trapped this inland ocean here, which extends all the way up to Yellowstone, up here to the north. When that drained off, at some point in the past, there would be many, many millions of years ago that this happened. However, now, here we are in the year 2015, and just like 1,000 years ago, we're starting to see some kind of new volcanic unrest happen with the plate. Now, this all ties together. I hope you guys understand what I'm trying to show you here, that the volcanism that's related is part of the geologic process of the formation of the United States and the formation of the plates overall. And as soon as you understand that, then you'll understand that this that we're seeing now is just the start of most likely what's going to be some kind of larger volcanic unrest event that's going to be taking place. It ties in with the methane releases that could be happening, for sure happening down here in South Canada, could be happening up here to the north. That might be the start of this big event that could lead to either large earthquake activity or volcanic activity. It's confirmed leading to at least some activity in the far west Pacific, causing volcanoes which haven't erupted in 1,000 years to show activity. Now we're starting to see that activity translate out over here on our side of the Pacific, which is showing up slightly differently, but we've got to keep watch. Got to keep watch at this point. Don't discount anything. Of course, look out for volcanic activity on the west coast, too, due to the amount of the activity happening around the rest of the Pacific. But on the central portion of the plate, going up to the northern portion of the plate, up here into Canada, this would be the ideal spot to see these methane releases, to see these earthquake events transpire after the methane releases transpire. So that's kind of what's already happened here. And I'm willing to bet that there's been other methane releases that have happened in the area that haven't been caught. The one at the golf course got caught. How many more are happening back up here in the back country that are not being caught? Worth investigating at this point. If you're a researcher, it kind of falls on you to do that. You can't rely on me. I'm not going to be getting out there in the back country to go investigate those places, and most likely no one else will either until it's far too late. Always have an earthquake plan ready, guys, and be prepared just in case.